what really makes or breaks a voice app is the latency. How long does it take for the system to respond after the user has given a command? Uh, Finding these latency leaks and fixing them is critical to making the voice app usable. So in another video, I showed a very basic voice to video app. So what happened there was I gave voice commands to change the video and the system responded by switching video in real time. It wasn't really real time. The delay between me giving command uh, and the application switching the video was substantial, and that really destroyed the user experience. So let's have a look at the demo again. Let me start the server. Now connect the client. So as soon as the client starts playing a default video. Now I want to switch the video. Google I/O. There's a noticeable delay before it changes to Google I/O. Let's try another one. Sam video. Yeah, so there's noticeable delay here, and this really breaks the user experience. We want it to react much more quickly. So the question is how do we debug it? The key problem is to know where. So let me show the overall diagram. So this is the overall diagram, and um, this is the pipeline starting with voice instruction, speech to text, large language model. It selects the video ID, and then a video processor which plays the video. Okay, so the delay could be happening in any of these steps. And so it's tricky to figure out where the error is. We need a systematic method to do that. So let's start with looking at the pipeline and seeing how we can systematically debug the latency here. So let's have a look at the code. This is implemented in using Pipecat, and this is the basic pipeline. That's the core of the application. Audio input, speech to text, aggregating for LLM, and then video processor, which switches the video. Okay. So Pipecat, all of the modules are in fully under control, so it's relatively easy to measure the latency of each of the modules. All you have to do is to enable this, add this flag, and that automatically starts logging time taken by each of the components of the pipeline, each of the frame processors. So this takes care of the default modules, STLLM, and then there is a new module that we added playing the video. For that, we have to add the time taken ourselves. So we'll go back and so this is the key in the process frame function. This is where it gets the frame, gets the video frame by frame. So if it takes more than 0.07 seconds, I print. So that will tell us the time taken in extracting the video switching was long. Okay, so with that enabled and already enabled that. So let's look at the logs here. So I said transcription. Okay, let's go back and yes. So this is an example of the flow. User started speaking, user stopped speaking. These are the events that it emits. Once I stop speaking, it collects the audio in buffer and passes it to Whisper. Whisper time to first frame is 2.4 seconds, 4.8 seconds, and which is since it is a short utterance, that's the whole processing time. So 2.48 seconds seems pretty big, and that might be the reason behind the whole thing, or latency. Let's also look at the LLM. I'm calling grok. Time to first buffer is 0.13 seconds. This is 135 milliseconds. This is pretty good, even though it's running on API, remote server. That's pretty good. The total processing time is 0.160 milliseconds. That's also pretty good. So it seems like this is the Whisper, the STT module is the problem. 2.48 seconds is completely unacceptable. This is where after the user speaks, Whisper, which is hosted locally on a not so powerful machine, is taking a lot of time. It's not optimized at all. So this is our guess that this module is taking up all the latency, and we'll fix it by switching Whisper to a remote API, remote STT service, DeepGram. So let's switch it. It's again pretty easy in Pipecat. This is the original line. Pipecat provides plugins for all of these STT and TTS API services. So make the change. Let's try to run it again. Okay, so this is the default thing running. Let me try. Google video. That was quick. Sam video. Awesome. So that was the issue. The local STT was taking a lot of time, and we were able to debug it by switching to the remote DeepGram service, and now we can check back. The DeepGram TTFB is 0.001. This is amazing, even though it's remote, so it's highly optimized, and the utterance is small, so it can finish the job in 0.001 second. And that really makes the whole pipeline fast. Now, actually, the LLM, which is taking 124 seconds or slightly more than that, is the bottleneck. It's taking 156 milliseconds, right? So we have now by switching to DeepGram, we have managed to solve that problem. So that was a quick example of how to debug the latency issues in an actual voice app built using Pipecat open source library. This was a relatively simple example, just enough to show how debugging latency looks like and how drastically it can improve the look and feel of the app. In production, we might encounter many more issues. For example, TTS modules, text-to-speech modules, add additional delay. There could be network traffic delays from different geographic regions where your app is deployed. If you're hosting models privately, say using Docker or Kubernetes, that may not be optimized, that may add delays. WebSockets, using WebSockets versus WebRTC or SIP servers, and so on. So there are quite a few issues that might lead to high latency in your app and make the UX not that efficient. So the learning lesson is that you need a robust framework to monitor the delays, latency of each of the components involved, and then to go about systematically fixing the delays, the reason for the additional latency.